Now remember, I said Linux is command line first. That's really not the best way to describe it, but I can't think of a better way right now, so we've got to break away from the CLI for a second and make sure that you got a graphical environment on all your distros. In a lot of situations, it doesn't make sense to load a GUI on a machine that you're going to use as a server. You would access it remotely through something called SSH Secure Shell, and then you would have a sort of a remote CLI. So here's Yum. It's what's called a package manager. Remember, I referred to software programs as packages. You're going to learn a lot about that. We're going to talk a ton about package managers in general. It's different, way different on all the distros, but for now, we're going to tell Yum to install a whole group of software packages, or just packages for short, that give us a graphical environment. So we're going to do Yum group install X Windows System Desktop. So this graphical environment that we're seeing is going to be based on GNOME, or GNOME. Now this is Red Hat. Before we get to Yum group install X Windows System, we are going to have to register this system with Red Hat in order to get updates, because that's how Red Hat works. Now if you opted for CentOS, you don't have to do this step. Now out of the box, Red Hat really doesn't do much for you. It is unlikely that your Red Hat machine is actually on the internet. So if you do ping www.google.com, it's not likely to work. It works in my case because I already got it working. You can do IPA, which will show you all of the interfaces in your system. And so chances are you'll see low, which stands for the loopback connection, which just means the local machine, but you should see something else. In my case, it's ENP0S3. Yours is likely to be something different. You can do DH client, because hopefully you have a DHCP server on your network. ENP0S3, or whatever the interface was. And when you do, you can do IPA, and it should show you that you now have an INET address. So now you should be able to ping Google. Great. We're on the internet. Now we can register the machine with Red Hat and get updates. So you can run subscription-manager, register, subscription manager, all one word, and it will register with the system. You'll have to enter the username and password that you provided at the Red Hat portal. And again, if you're on CentOS, DHCP will have been enabled by default, very likely. If not, you can run the DH client and do the IP command, it's fine. Then you can do subscription manager attach -- auto. And then you can finally run yum update and get a reasonable set of commands. Now, you'll notice that this command says, oh, you must be the admin user to do something, and I type sudo ! ! Means repeat the previous command, and sudo means become the administrative user. So this has got to install 5 packages and upgrade 59 packages from the DVD that we just downloaded. So it's a little bit more involved. But we're still on task to enable the GUI. We just got to do some other stuff first. But yep. Great, we're done. Now we can do yum group install. And again, I forgot to be root. So root's the admin user. We get there some different ways. Yeah, look at that. It's got to install 11 packages and 248 dependent packages. So wouldn't you have liked to have specified all that on the command line? Because it's like this depends on this, depends on this, depends on this, depends on this. There are groups of packages, though, to make your life easier. And when we learn how to use yum later, you can get a list of the things that are available. So if you're a developer, you can install development tools. If you're building a web server, you can install the stuff that you need for web development stuff. Database servers, MySQL, PostgreSQL, MariaDB, MongoDB, whatever your poison. It's fine. It's all in groups. You may also be starting to get clued in a little bit that, even though by convention these distros are a lot different, already we're in a much different situation because, with Debian, it's basically ready to go out of the box. With CentOS, it's basically ready to go out of the box. With Red Hat, and also on the SUSE side, It's like, well, it's kind of commercial. We want you to be a subscriber. You should have a subscription service. And Red Hat does offer free subscriptions for developmental and testing purposes and things like that, and that's why our system activated. And if you go to the web portal, like if you go back to where you signed up for an account and you look, you'll actually see this system on the web. And so for an enterprise, it's easy to think that you add 10, 20, 100 systems and it shows up on the web. You can keep an eye on all of them from the web. It's like, are they getting their updates? Is everything being deployed correctly? Is something going wrong? You sort of get a freebie management portal with all of the other licensing and everything else that goes with the distribution. And so when this is done, we should be in a graphical environment on Red Hat. And the default graphical environment on Red Hat is GNOME, much like Ubuntu, even though this course is not going to cover Ubuntu or Ubuntu, and just like Debian, which is GNOME. And we could have picked GNOME for OpenSUSE, but we picked KDE to be different because we're rebels. And yeah, gonna learn stuff. Woo! They should also know that GNOME is highly customizable, so it may look, different, completely different between different distros. In fact, Ubuntu, which I mentioned before, is another popular Linux distro, and you'll recall from the family tree that it's actually based on Debian. Until very recently, it used its own graphical environment called Unity, but it now uses GNOME. So GNOME won out in the end. Sometimes you might see these referred to as window managers, but that's not really technically accurate. They're desktop environments. So not just Unity and GNOME, there's also the KDE Plasma. Sometimes you see KDE as the K desktop environment. That's what we're going to be using on OpenSUSE. So there's a lot of names for things. You see so many developers are working on so many different things for Linux that there are tons and tons and tons of different programs that provide similar functions or similar functionality, but go about it in different ways. These programs need to provide standardized protocol so that the apps that you want to run can draw stuff and you see graphics on your card, on your screen and things like that. Think about it. You've got graphics cards from Intel, NVIDIA, Radeon Technologies Group, other companies. How do you draw a box on those different graphics cards? The hardware is different. The software's got to be different, right? So should your word processing application care about what graphics card you have? No, that's crazy. There has to be a standardized protocol so that the word processing program can provide generic instructions for rendering its interface. Interestingly, at the time of this video, the lowest levels of that functionality and protocol stack is changing. It's undergoing upheaval and major change, basically. There's two major compositing window managers. That's what they're called right now, X11 and Wayland. Strictly speaking, X11 and Wayland are just the names of the protocol for how to do this. Just be aware of those terms. Xorg and Weston are the names of some programs that implement those protocols. So you can switch between classic Xorg, which implements X11 protocol, and the ancient X11 protocol, and Wayland in a lot of distributions by clicking the gear like we saw in Debian. It would just be another option in that menu. But these are kind of old and standard, and they haven't adopted Wayland yet. So you should just be aware that that's coming. The goal with Wayland is to get the draw and paint operations faster and closer to bare metal than is possible with the older protocols like X11. Well, now that we've got our graphical environment installed, let's take a look at it. So we downloaded our graphical environment, and we're still at a text environment. What does this mean? Well, getting way ahead of ourselves here, but there are different run levels that you can enter on the system. Run level is sort of the key word there. And so when you boot the system, I talked about in emergency mode, you can go into single user mode. That is an option. Multi-user mode is run level 3, and run level 5 is the graphical environment. And so by default, if we use systemctl get default, my default run level is multi-user.target. And so that is, again, by convention, we're going to boot into the text mode environment. We're not going to boot into the graphical environment. If you're old enough to have used both DOS and Windows, this is like just booting strictly into DOS and not automatically running Windows. But so Windows since '95 will just boot right on up. So it's an unusual situation. This is all managed by a program called systemd. So the kernel hands off to systemd to do all of this fancy complicated stuff with starting all the programs and managing the run level and making sure all that happens. That was not always the case. Systemd is a relatively recent change. There was something else called system V, system 5, system V. It depends on, you might see it as sysv or system 5 or whatever. init. And this was just a series of shell scripts. And the shell script is just a text program like somebody was typing out commands, but it's inside a file to do stuff. And it turns out that you can't do super complicated things with that. Like maybe starting the network server depends on something else having been started, or starting the database server depends on the network having been started. And so in order to accomplish that, you had to jump through some hoops and do some crazy stuff. It was very simple. Systemd, very complicated. You will see a lot of complaints on the internet that Systemd, does a lot of stuff unnecessarily and is overly complicated and that sort of thing. And it used to be that we could just change one text file in the configuration directory and change the run level, but now we have to use systemctl. So I'm going to use systemctl set default graphical.target. Again, I have to be root. So I would just run sudo with that, and then that would work fine. And so it's telling me that it's doing something. Now, if you remember to type sudo, you don't have to do sudo exclamation point. So see if I hit up, if you just type this command to begin with, sudo systemctl blah, blah, because you remembered that you're not root, you remembered that you're not the admin user, then it's totally fine. So we've got that. Now we're going to reboot. Don't have to reboot. You could change the run level right there, but this is fine. Hey, look, we got an update. We got an extra option here. Notice that our kernel version incremented a little bit. We went from EL7 to EL11. There was an extra entry on that menu because we applied updates to the system. Starting to catch on now, right? Yeah, I think so. All right, so to recap, we're still on our quest to get Red Hat to boot into a graphical environment. And, we sort of manually configured the network. I want to show you two commands, nmcli and nmtui. Now, nmcli is a command line utility that lets you configure your network card. And so when you run nmcli, you can specify on the command line how you want to configure your network. This is really handy in shell scripts or any kind of automation that you might do later. If you write a little program to, automatically set up your network or automatically configure something, you can do that with nmcli. nmtui gives you this, which is kind of a graphical environment at the command line, but not really. So this boxes thing, see, we've got some buttons here, and we can click OK, and we can tab between them, and I'm just using the arrow keys. This is called curses. Well, more specifically, ncurses. This is the library is called ncurses. When we get into kernel configuration later and you do make menu config, menu in the menu config gives you a curses menu where you can do stuff, or ncurses is the library, ncurses 3. And so there are several utilities in the Red Hat distro that are a curses interface to common system administration things. So when you're running a Red Hat server and you don't want to run a full bore GUI, you've got the option of running something like this, which is pretty user-friendly. So we can do edit a connection, and we can see that we've got some network options configured here. And if we want to configure it to come up automatically, we can hit edit on one of these, and we can do automatically connect. I'm just hitting tab and then space to mark it, and X means automatically connect. Yours probably won't be set on automatically connect, and probably available to all users should be set as well. Literally just going to hit OK, although you can do, an IPv4 configuration. You can do automatic, and IPv6 is link local. In my case, maybe you have IPv6 on your network. You can configure that. Look through those options and be familiar with that. It's not really a networking course, so I'm not going to go super detailed into IP addresses and subnetting and routes and gateways and things like that, but you can configure all of that manually under the IPv4 and IPv6. Well, IPv6 not really, but IPv4 on the configuration on that. You should be okay. In my case, I've got a bridge. You may not have a bridge. That is okay. You do activate a connection. It's like we got a little star next to the connections that are activated. That's good. So, and then you can also set the system host name so we can name it. So right now it's localhost.localdomain. Going to change it to forgreatlearn.localdomain. It's like set host name to forgreatlearn. We're going to quit. Now notice it still says root localhost. It's because I haven't rebooted or exited or anything. So there you go. Now we should be able to start X. So I'm just going to reboot the system, and it should just go right into X because of the other stuff that we did. We installed all the dependencies, and it should take us into the GNOME Display Manager GDM login screen, just like our other distro, our Debian distro, and like our OpenSUSE as well, except with KDE instead of GNOME. So you can see our Red Hat system is restarting. Looks like it's taking us into GNOME. We're in GNOME. This is GDM. As we can see from our GNOME screen, we've got some options. There's an accessibility menu up here where you can turn on high contrast, zoom, large text. This will be pretty much the same on most GNOME systems unless they have accessibility disabled for whatever reason. You can read more about these features in accessibility. I'm not going to go into them. On-screen keyboard, sticky keys, mouse keys, that sort of thing. You can see here that our network connection is enabled. We've got a wired connection. GNOME on the login screen really doesn't give you a lot of info. You can also see that we've got the sound control. We've also got power control here where we could, shut down the system if no one is logged in. So that's a neat feature. Not listed, we could log in as root, for example, although you wouldn't really want to recommend it. It is possible to have normal user accounts that are not listed on the screen. So see if logged in as root at the graphical prompt instead of my regular user. That's an option that you can do, although not generally recommended. And I mean, I can't think of a legit reason why you'd need to do that off the top of my head. I'm gonna go ahead and log out. You should just be aware that, you can have a user account on your system that doesn't show up in the login screen that somebody could log in as using the not listed account. And it makes a lot of sense too if you hook up your computer to Active Directory or LDAP or some other federated login system where it doesn't necessarily know who's going to be logging in here, and so it can't just pre-populate it. This list comes from the local system, just so you know. I mean, it's not super important, but just so you're aware, that's how that works.